Hello everybody, so this is Mr. Bowman. Today we're going to be looking at the ALEX topic, solving a system of linear equations with decimal coefficients. So similar to when we solved the fractional coefficients, our first step is going to try to get rid of them. And we're going to do that by looking at our various coefficients and figuring out which ones have the most decimal places. So we have 2 here, 2 here, 2 here, 2 here, 2 here, and 2 here. So this one's nice and consistent for us. So what we're going to do is pick a number to multiply everything by to get rid of those decimals. So since they all had 2 decimal places, I'm going to multiply by 100. And that you can either remember that they go to the hundredths place, so tenths then hundredth place, or my preferred method is there's 2 decimal places, I need something with a 1 and 2 zeros. If there were 3 decimal places, it'd be 1 and 3 zeros, or 1,000. So if I multiply everything by 100, and that's to both equations, we should lose all of those decimals, then we won't have to worry about them anymore. Okay. So the top one turns into 25x plus 3y equals negative 81. And then the next one turns into negative 5x plus 2y equals 11. Okay. And then we have one of our normal systems. So this one looks like it's set up to easily do an elimination one because I have a 25x up here and a negative 5x there. So if I multiply this bottom piece by 5, I'll have a positive 25 and a negative 25. So we'll go ahead and multiply everything on the bottom one by 5, which will give me a new equation of negative 25x plus 10y, don't forget to distribute that to both, okay, equals 55. And then the first one I'm not changing, so I'm going to just bring that over as 25x plus 3y equals negative 81. All right, so now that I have that, I can go ahead and actually just combine now. So 25x and negative 25x drop out. So I move to my y's, and I have 13y, 3y plus 10y. And then over here, I have a negative 81 plus 55, which I believe lands me at negative 26, which is looking promising because when I divide these by 13, I should end up with negative 2. So that's my y answer over here. And remember, you do need both of them. We're looking for an intersection point. So I have y. I also need x, so I can have that x comma y point. So I'm going to take that answer that I just found, that y solution, if you will, of negative 2, and come back. And usually we want to plug it into one of the original ones. But just like we did when we did the fraction ones, I'm actually going to go to the ones after I eliminated the decimals because it'll make my life a little bit easier. And I'm pretty confident I did those correctly. So I'm going to choose this bottom one because the numbers are a little smaller. So let's go back to red. And I'm going to have negative 5x plus 2 times negative 2 equals 11. So this is before I multiplied by 5. It's the original changed one, which is a terrible way of phrasing it, but that's fine. So negative 5x, when I clean this up, that was sloppy. I will rewrite that. Negative 5x minus 4 equals 11. When I add 4 to both sides, I get negative 5x equals 15, which then I will divide by negative 5 and find out that x equals negative 3. So my intersection point is, not sure what happened there, negative 3 comma negative 2.